Welcome to Schweitzer Drive, a podcast where we explore what goes on between the generation of electricity and the light switch. Join Dave Whitehead as he interviews the entrepreneurs, innovators, and experts who are inventing the future of electric power.
Bath County, Virginia is known for its pristine scenic beauty and rustic rural charm. It's also home to the largest battery in the world. In today's episode, I'm talking with Brian Starling at Dominion Energy. Dominion manages Bath County Pump Storage Station, which can generate enough energy to power 750,000 homes and is considered to be the largest pump storage operation in the world. Brian joined Dominion Energy in 2003 as an intern. Over the years, he has worked on testing, installing, and repairing relay systems and calculating impedances in relay settings. He also has extensive experience analyzing and documenting transmission, distribution, and generation operations. Brian is a strong programmer and looks for innovative ways to automate processes, reducing response time and eliminating errors. He is currently manager of system protection engineering at Dominion, responsible for misoperation investigation, construction and O&M protection settings, and SCADA data communications. Welcome, Brian.
Thanks, Dave.
Will you explain what pump storage is and how it actually works?
Sure. So pump storage is actually a very simple concept. So think of it as an energy storage system, but instead of using a battery, we're using mechanical storage to actually store energy. So when you have a good location, such as Bath County, where you have a high elevation, you can put one lake at the top of the mountain and have a lake at the bottom of the mountain and your power station in between. During normal operation, electricity is formed when the water from the upper lake flows down, spins the generator to make electricity. However, during certain situations and certain circumstances, you may have more electricity on the grid than you actually need. What we can do then is turn the generator around backwards, essentially, and allow it to pump the water back up the mountain, and therefore it's storing the energy. Currently, that Bath County facility has 6 units. Each of them operate at 500 megawatts.
In the Bath County storage system, is it 2 lakes, or is there a river going by and you take water out of the river as it goes by and store it in the upper lake and then put it back into the river and let the water go downstream?
At this particular installation, there are 2 separate lakes. We call them the upper pond and the lower lake. However, they're about the same size.
Okay.
And neither one of them is river fed.
Okay. Where do you get your water from then?
So the water is actually, it was brought in on site. So it's the way the valley collects the water from the rainwater. It's got a large basin, similar to a quarry, and the water will fill up that quarry naturally. And then we use that water to pump up and down.
Wow. Self-contained system. That sounds pretty cool. Brian, what are the main benefits of pump storage?
So the main benefits of pump storage, this facility that we're talking about today was built in the early 80s, and it was designed because of the nuclear boom that was happening in the country at that time. The thought would be we would have more nuclear power than we would know what to do with. However, we would need that energy at other peak times when there would not be enough. So hence the purpose of Bath County was to store all that residual nuclear power that we couldn't use at the time. Remember, nuclear reactors their reactor fuel is good for a certain number of years. It doesn't matter how much or how little you use it. So the benefit would be to let your nuclear reactors run full time and then store that extra energy. Nowadays, the main purpose of the pump storage is to harness the power of the sun and wind. When the wind is blowing and the sun is shining, we can harness that power and store it for periods of time when the wind is not blowing and the sun is not shining.
I mentioned in the intro, Dominion runs the largest pump storage facility in the world. Will you talk about the history of the facility and share a few details about the technology, operation, and benefit to Dominion customers?
It is the largest pump storage facility in the world currently. Dominion is also looking at purchasing some areas where we could add additional pump storage. Right now, we're looking into the abandoned coal mines in the southern part of the state. We can use the mines to store the water as opposed to using a mountain and a lake. However, the concept is relatively the same. The technology there is designed so the system can be turned around in a matter of minutes. So if it's generating and all of a sudden we need to store, we can shut off the water. We can open one circuit breaker, close another circuit breaker, which will essentially turn the motor around backwards. And then we can start pumping the water back up the hill again. Other operational benefits of a pump storage facility is not only can we use it as a battery, but we can use it for what we call VAR control or voltage control on the system. We can change the electric field in the generators or the motors, and that will allow us to either increase or lower the voltage on the system without having to install other expensive equipment such as capacitors or reactors.
That's pretty cool. I just remember, this is going way back when I was taking motors and rotors classes, right? You have the E and the V of the machine, and depending on what their angle relationship is, one makes it a generator and one makes it a motor, and you can do all kinds of cool stuff with it then. Why aren't we seeing more pump storage operations being built today, do you think?
Well, first of all, there's only so many good places to build them. Either you have to have a good facility where you can have an upper reservoir and a lower reservoir. You do see some of them being built at typical or traditional hydroelectric facilities. That would just be a dam, where if the river is high enough, you can pump water back into the reservoir above it. We do have a few locations where when areas were flooded in the, say, early 1950s, that creeks started to back up. So then they would pump water back up the hill. However, those areas are limited. Obviously, building dams is something that we frown upon, and it's not something that we try to do anymore just because of the effects it has on the ecosystems. Also, the amount of land required to purchase and do an upper reservoir and a lower reservoir is quite extensive. Those reservoirs have to be closed to the public, and that's just because of the maximum amount of water that could be pumped out or pushed in at any moment could develop very hazardous conditions for swimmers or boaters. So therefore, those areas are not open to the public for anything, including fishing.
Out here, we have a handful of pump storage places, and we're kind of fortunate because we have a mountainous region. So it's easy to, block up a canyon to pump water in. How does that compare, I guess, to out east? Because I don't think of, say, Virginia, maybe the Smoky Mountains or something like that has some mountainous areas. But I generally think of the East Coast as a fairly flat part of our country. Where else might pump storage have some application just from a geographical standpoint, do you think?
So we do have the Allegheny Mountains that come up the East Coast, pretty much one state line in, and that includes the Smokies. Tennessee Valley Authority has quite a bit of pump storage being built up in the mountains, using the same concepts with the canyons, pumping water in, blocking them off. The other thing that we're looking to do right now is, use abandoned coal mines. And you don't have to do this with water. You can do it with air pressure as well. So that is something that we're exploring, using the abandoned coal mines that have either filled up with water over the years and using those as pump storage facilities. We're using the same concept with air pressure, where we could possibly pump air into the mines when we have additional power on the grid, and then allowing it to come back out and spin the fan the other way, which would become a generator and put power back onto the grid.
How does water and air compare from an efficiency standpoint or practical application standpoint?
So I think it all depends on what your losses are on the mine, right? If the mine is completely sealed, then you're going to have a pretty good, air system to store your energy. Uh-huh. If you have leaks, or you eventually have what we call blowouts, where the rock is thinned to the surface, then you're going to have a lot of losses in your system at that point. Where water is much easier to contain, water also has a much higher density. So you get a little bit more energy when it pushes against the blades of a turbine as opposed to air.
Who's using air right now in a I guess a deployed or practical application manner right now?
I'm not familiar with the exact company right now. The research is going in Tazewell, Virginia, which is down in the southwestern Panhandle, close to the Kentucky-Tennessee lines. A lot of abandoned mines in that area, but that is where they're doing the research to find out if it will be a viable alternative. And my understanding is the main reason for doing that is there's less environmental impact when you're injecting air into something than when you're running water and possibly having that water then contaminate other water sources.
Oh, that's interesting. So right now, air is kind of in that experimental or design phase. I could see a lot of benefit, I guess, for the air. You don't have to worry about swimmers and releasing water or something like that. I guess releasing air back into the atmosphere is not necessarily a bad thing. I'm sure we can always think of some unintended consequences that might hurt or damage something. But that's really interesting. When you look ahead 25 to 50 years, what does the future of pump storage look like, and where will it be in the energy mix? Is it going to be Could it be 5% of our energy portfolio or larger?
Well, I think that all depends on the time of the year and the time of the day. We could have definitely pump storage is going to be a part of our energy future. There's no way around it. Battery technology, while it is great, it is not abundant. The cost of the batteries and then how do we handle them when it's time to dispose of them are still questions that we have not answered. So we need to find a way to store energy from renewable sources that we can then use later. And pump storage is the environmentally friendly way to handle that situation. What we would like to do is we would like to see more pump storage created in the areas that it's needed a little bit more. So not too far from urban areas. And you don't have to install a massive lake on the upside and the downside to do something like this. You could do it on a smaller scale using just water towers like you see on the tops of movie sets and things of that nature, where you could pump water into these old water towers when you have additional power and then allow it to run back down when you do not. Now, the size of the unit would not be as large as what we have at Bath County. However, for a small scale application, if you installed many of these, you'd be able to store a lot of electricity with very little real estate. The other thing we would like to see more of is that we have the mining systems. That is definitely a possibility because there are mines all over the country that are currently abandoned and not being used. This could be a good solution for some of those mines and some of those towns that have been closed due to the mining. It could be a good economic boost for facilities like that. Bringing in a power station that is a good source for green energy into some of these abandoned coal towns is a good environmental use of that facility at this point. So, but when we look ahead 25 to 50 years, remember, most states have enacted some form of legislation that will require their states to be carbon neutral by a certain date. Dominion is looking to be carbon neutral and has certain dates by 2045-ish. However, Dominion has set an internal goal to be completely carbon neutral by 2050. So the only way we're going to be able to accomplish that using renewable energy will be use some kind of a storage system. We have Bath County built. We're looking at additional sites in the mountains right now. We are committed to the Tazewell facility. What that commitment may look like in 25 to 50 years as far as the size and scale, that is yet to be determined. However, we are committed to pump storage. Bath County is not going anywhere. It's in good operational shape. It has no known design flaws where it's going to be coming offline, at the end of any certain lifespan period. We are planning to operate that facility for the foreseeable future. I would challenge other utilities to investigate more about possible pump storage operations in their service territories or even beyond.
Brian, like you, I'm a huge fan of pump storage. I think it is the best battery, I don't know, that we're going to conceive of in a very, very long time. I don't think traditional chemical batteries get us to where we need on a large scale.
And just think of the size of a 3,000 megawatt or 3 gigawatt battery array and all the inverters and all the infrastructure that would have to go into a facility like that. The footprint would be several square miles, where this facility is all contained, and I don't know the exact dimensions off the top of my head, but probably in less than 1 square mile. Yeah, that's some really cool stuff. And then how do you measure your pump storage facility like you would with a traditional lithium ion battery, where they'll do it in megawatt hours? What are the megawatt hours for Bath County? So I'm sure there is some conversion factor, but right now we measure the feet of water in that upper reservoir. And that's the number that we communicate. So that's how much energy we know we have stored up. I'm sure there is some conversion factor, and I know they can drop that. I think it's 11 feet an hour if they're full out running 3,000 megawatts. I don't know the exact depth of the reservoir as of right now, or what it has been, or what its typical running levels are, but I can look that up and I can get that back to you.
Yeah, that'd be interesting, because all I can think of is I bet it is way more than, say, the 4 hours you get out of like a megawatt battery hour or megawatt battery. Hey, Brian, thank you very much for talking about pump storage today. This is a fascinating subject. I'd love to have you back on when you have your next facility up and running to see how it's performing. And I bet by then, too, we'll have a lot of other competing energy storage systems, whether it's batteries or others online, too. This is, I think, one of the great solutions we have in front of us when we talk about having net carbon neutral solutions going forward to complement all the other energy sources we have.
Thank you for having me, David. I really enjoyed this talk.
Thank you for stopping by Schweitzer Drive. Join us again as we learn about, explore, and celebrate electric power. For more information about the show, please visit selinc.com/Schweitzer Drive.